Hi, 4th and 5th graders. Today in science, I want to talk to you about how energy is all around. What does a melting scoop of ice cream have in common with a kicked soccer ball? The ice cream and the ball both change in some way, but what causes these changes? Well, that's energy. Think about all the ways that you use energy. Energy is the ability to cause changes in matter. Energy is involved when matter moves or changes its shape. A change in temperature also involves energy. Energy can transform or change from one form to another. The boy is in this picture is using energy to run. The energy comes from food that he ate. When the boy kicks the ball, his foot transfers his energy to the ball. The moving ball transfers energy again. Energy moves to particles in the air and on the ground. These tiny particles begin to move faster. The ball stops moving after it's transferred all of its energy. Energy is never used up. It just changes from one form to another. These are some important things to know about energy. So, the tiny particles in ice cream, when it's solid, those particles are moving slowly. Energy from the sun causes a change in their motion, and those particles start to move faster. The ice cream begins to melt, it's changing state, and it becomes a liquid. What's causing that? Energy from the sun. The energy changes so that those particles speed up. Ups and downs of energy. Does an object that's not moving have any energy? Let's find out. Because you're telling me that energy is never used up, it has to go somewhere. Does a book sitting on a shelf have energy? Yes. Someone gave it energy by lifting the book to the shelf. It had to get there somehow. The energy is now stored in the book. The energy an object has because of its position or the condition it's in, we call it its potential energy, or we abbreviate it PE. If a book falls off the shelf or it begins moving, its potential energy changes into energy of motion, and we call that kinetic energy. Energy caused, an energy an object has because of its motion. Take, for instance, a roller coaster. When the roller coaster car is at the top of a hill, it's not moving. Most of its energy is potential energy. Due to its position, it stopped there, but something was making it move at first. Gravity is going to change the PE to KE, kinetic energy, as the car starts to go downhill. When you compress a spring, like in a slinky, or inside of your pen, if you compress that spring, or you take a rubber band and you stretch it, your energy is stored in that object. That's its potential energy. That energy is sitting there stored in there. The potential energy changes to kinetic energy when you release the spring after compressing it, or you release the rubber band after stretching it out. That's its motion. Position isn't the only way that energy can be stored. A match head has potential energy stored in its chemical bonds between its particles. Think about a match in the head. When you strike the match, it releases its stored energy as heat and light. A charged battery also contains potential energy. A battery dies when all of its potential energy has been transformed to electrical energy. The kinetic energy of a moving roller coaster car is easy to see. How can you sense energy in tiny particles of matter that are too small to see? When a trumpet makes noise, it vibrates or it moves back and forth. The trumpet transfers energy to tiny particles of air. Each particle of air moves back and forth, bumping into other particles. The sound travels outward. If someone knocks on your door, the particles in the door vibrate, and that's what makes the sound. They bump into particles in the air on your side of the door. The sound travels through the door and through the air to you as a sound wave. So sound energy is a form of energy that's carried in waves in vibrating matter. a type of kinetic energy because the particles of matter are moving, and the cause of all the sounds that you hear. Like when you blow a trumpet, all the sound particles are going out that way. That's the direction that the sound waves are traveling. Well, another type of energy that involves moving particles is thermal energy. So sound energy is kinetic energy. Thermal energy is also kinetic energy. It is the total kinetic energy of the particles that make up a substance. Thermometers measure thermal energy. Think thermal, you think heat. You sense thermal energy as temperature. The more thermal energy an object has, the greater its temperature. Thermal energy helps you to stay warm, to cook your food, and to heat water for washing or bathing. This is a very important type of energy for us. Another type of energy is light energy. Your ears use sound energy to hear. What kind of energy allows your eyes to see? Suppose you're using a flashlight in a dark room. You drop the flashlight and it breaks. What can you see? Nothing. Your eyes need light energy to work. Light energy is a form of energy that can travel through space. Light can also pass through some types of matter, such as air or glass. Light energy travels as waves. You can see light energy. Some objects give off light. You see all other objects when light reflects or bounces off from them and enters your eyes. Can you think of 3 sources of light? I can think of one. The sun. On our lamps, light bulbs. Fire. Lightning bugs, even more that you might think of. Electrical energy changes to light energy in things like a flashlight. Objects that give off light energy often give off heat. We talked about that the other day when we were doing chemical changes. But the 2 types of energy are different. You can tell them apart by the way you sense the energy. Your skin senses heat, but it cannot sense the light. So it cannot sense light energy. Your eyes sense the light energy. So there's different things that detect it. Flashlights and television sets produce light. To do this, they use another type of energy. We call that electrical energy. Electrical energy is energy caused by the movement of electrical charges. When you use electricity, you are using electrical energy. Electrical energy can change to other types of energy you can use. Electrical energy changes to thermal energy, like in a toaster or a stove. Cell phones and stereo speakers use electrical energy to produce sound energy. And lamps and spotlights, electrical energy changes to light energy. You have learned about machines that use electrical energy. Some machines don't need to be plugged in. What forms of energy do they use? Many objects, such as a ball being thrown in the air, have both kinetic and potential energy. We call that mechanical energy. Mechanical energy is the total energy of motion and position of an object. As a ball drops, its potential energy decreases as its kinetic energy increases. Its mechanical energy, though, stays constant. The relationship between these forms of energy is shown by this equation. Mechanical energy equals kinetic energy plus potential energy. A machine uses mechanical energy to do work. For example, a fan plugged into the wall uses electrical energy. It changes that energy into the mechanical energy of the spinning fan blades. The spinning fan uses the mechanical energy to do work, moving the air in a room. Have you ever felt as if you were going to run out of energy? The energy your body uses comes from the foods you eat. Food contains a kind of potential energy called chemical energy. Chemical energy is energy that's stored in matter and can be released by a chemical reaction. When your body needs energy, it breaks down food and releases potential chemical energy from it. If you use that energy to run or jump, it changes into kinetic energy. Your body also uses chemical energy stored in food to produce thermal energy. This keeps your body at a steady temperature. Cars use chemical energy and liquid fuels such as gasoline. A flashlight uses the chemical energy stored in a battery to produce light. Some stoves change chemical energy to thermal energy by burning a gas called propane. Well, boys and girls, that's all I have to tell you about energy today. Check out and see if you can find sources of energy around our school or around your home. Happy learning!